You think you know what time is? You check your watch, you show up for appointments, you remember yesterday and plan for tomorrow. You've been experiencing time every single second of your entire life. It feels like the most obvious thing in the universe. Time flows. It moves forward. 1 second per second, always. Everyone experiences the same moment together, right now, simultaneously across the whole world. Here's the problem, none of that is true. Not one word of it. And the person who discovered this, who proved that everything you think about time is spectacularly wrong, was a 26-year-old patent clerk who thought about it while riding a streetcar. Let's start with something Einstein himself asked when he was young. What would happen if you could ride alongside a beam of light? If light is traveling at 186,000 miles per second, and you're also going 186,000 miles per second right next to it, wouldn't the light appear to be standing still? Like when you're on the highway and another car is going the same speed, it looks stationary next to you. This question bothered Einstein for years. Because if light could appear stationary, that would break everything we know about electricity and magnetism. The equations say light must always move at light speed. Always. No exceptions. But that makes no sense with how we think motion works. So Einstein made a choice that changed everything. He decided to trust the equations. Light always moves at 186,000 miles per second, no matter who's measuring it or how fast they're moving. This one assumption, this single stubborn fact, means that time itself cannot be what we think it is. Here's the thing nobody tells you: time is not universal. There is no cosmic clock ticking away the same for everyone. Right now, this very moment, you and I are not experiencing time at the same rate. You just don't notice because the difference is incredibly tiny. Let me give you an everyday example. You've been on an airplane, right? While you were flying from one city to another, let's say a 5-hour flight, your watch ticked forward 5 hours. Makes sense. But here's what actually happened. Time moved slightly slower for you than for people on the ground. The difference is tiny, about 10 nanoseconds, but it's real. Your body aged less than people who stayed on Earth. By a tiny, tiny amount, but measurably less. This isn't a malfunction. This isn't an error. This is the universe operating exactly as Einstein described. Time itself runs at different speeds depending on how fast you're moving. You're thinking, that's ridiculous. How can time change speed? Time is just time. This is where your intuition completely betrays you. Time is not separate from space. They're woven together into what Einstein called spacetime. When you move through space, you're also moving through time, and there's a trade-off between the two. Think about it this way. Imagine you're walking north at 3 miles per hour. Simple. Now you turn slightly northeast. You're still walking at 3 miles per hour total, but now some of that speed is going north and some is going east. The faster you go east, the slower your northward progress becomes, even though your total speed stays the same. Moving through spacetime works like this. Everything, always, is moving through spacetime at exactly the speed of light. Yes, even you, sitting still right now. You're moving through time at the speed of light. When you start moving through space, some of that motion through time gets converted into motion through space. The faster you move through space, the slower you move through time. This is why time slows down when you move fast. You're not moving through time as quickly because you're spending some of your motion on moving through space instead. Light itself moves through space at maximum speed, so it doesn't move through time at all. From a photon's perspective, no time passes. Ever. Let me give you another everyday example Einstein himself used. You're standing on a train platform. A train goes past you at high speed. On that train, someone walks from the back of the car to the front, taking 10 seconds by their watch. You watch from the platform. You see the same person walk the same distance, but because the train is also moving, the person travels a longer path from your perspective. They're moving with the train and walking forward. Longer path, but they still take 10 seconds by their own watch. Here's the thing, you measure it taking more than 10 seconds. Not because they're walking slower, but because time itself is running slower on that moving train. Your 10 seconds and their 10 seconds are not the same duration. You're both right, but you're experiencing different flows of time. This means there's no such thing as now that applies everywhere. When you say something is happening right now on the other side of the world, you're wrong. There's no universal now. Different observers, moving at different speeds, will disagree about what events are simultaneous. Your now and my now are different if we're moving relative to each other. Einstein figured this out by taking time seriously. Not as some absolute river flowing through the universe, but as something that can be measured, something physical. He asked, how do we actually know what time it is? You look at a clock. But what are you really doing? You're looking at light that bounced off the clock face and traveled to your eye. Light takes time to travel. If the clock is across the room, you're seeing it as it was a tiny fraction of a second ago. If you want to synchronize two clocks in two different places, you have to account for the time it takes for light signals to travel between them. This sounds like a technicality. It's not. It's the whole game. Once Einstein realized that all measurements of time depend on light signals, and light always travels at the same speed for everyone, the rest follows inevitably. Time must be relative. Here's where it gets personal. You've probably heard that astronauts age slightly slower than people on Earth. This is absolutely true. Astronauts on the International Space Station are moving at about 17,500 miles per hour. After 6 months in space, they've aged about 0.005 seconds less than people on the ground. It's tiny, but it's real. Their body clocks, their cells, their radioactive atoms, everything about them experienced less time. The fastest humans have ever traveled were the Apollo astronauts going to the moon. For them, the time dilation was even more pronounced, though still tiny by everyday standards. But imagine if we could build a ship that goes 87% the speed of light. Spend 1 year on that ship, and 10 years pass on Earth. Your twin brother ages 10 years while you age 1. This isn't science fiction. This is what Einstein's equations predict, and every experiment we've ever done confirms it. Particles moving at high speed in accelerators live longer than identical stationary particles. Their internal clocks run slower. Atomic clocks on airplanes tick at different rates than atomic clocks on the ground. GPS satellites have to constantly adjust for time dilation, or your phone's map would be wrong by miles. The universe is telling us something profound. Time is not a stage where events happen. Time is part of the events themselves. Time is flexible, stretchable, relative. But wait, there's more. Time doesn't just slow down when you move fast. Time also slows down in gravity. This is Einstein's next revolution. Gravity isn't a force pulling on things. Gravity is the bending of spacetime itself. Stand on Earth's surface. Time runs slightly slower for you than for someone in orbit above you. The difference is tiny, about 20 nanoseconds per day, but GPS satellites have to account for this. They're further from Earth's gravity, so time runs faster for them. If we didn't correct for this, GPS would drift by miles every day. The closer you get to a massive object, the slower time runs. If you could survive near a black hole, time would slow dramatically. 1 hour near the black hole could equal 7 years back on Earth. This actually happens. This is real physics, not fiction. Einstein discovered this by thinking about falling. If you're in an elevator and the cable snaps, you're in free fall. While falling, you feel weightless. Everything in the elevator with you also feels weightless. From inside that falling elevator, you can't tell the difference between falling and floating in deep space with no gravity at all. This simple observation, that gravity and acceleration are indistinguishable, led Einstein to realize that gravity must be geometry. Mass bends space and time, and that bending is what we experience as gravity. Time runs slower in bent spacetime. Here's the final twist that brings it all home. You experience time as flowing forward. Past, present, future, in that order. But Einstein's equations don't care about that order. They work just as well running backward. The math treats all of time, past and future, as equally real, all existing together in four-dimensional space-time. You are not moving through time like a boat down a river. You exist as a four-dimensional object stretched through space-time. Your past self, your present self, your future self, all equally real, all existing in different locations in space-time. You perceive only one slice at a time, the slice you call now, but the whole thing exists. This is called the block universe. All of time, all at once, a frozen four-dimensional structure. What you experience as the flow of time is just your consciousness moving through this structure, experiencing one moment after another. But they're all there, always, unchanging. So what is time? Time is the fourth dimension. Time is what keeps everything from happening at once. Time is relative, flexible, inseparable from space. Time is geometry. Time is what you measure with a clock, and different clocks in different places tick at different rates. Einstein figured this out by trusting experiments over intuition. By asking simple questions about simple situations. By being willing to abandon common sense when common sense contradicted reality. You check your watch. Time moves forward. You think you understand. You don't. Nobody does, not completely. We just have equations that work. And those equations tell us we live in a universe where time is not what it seems, where past and future might all exist simultaneously, where every moment is frozen in the geometry of space-time. That's time. Now you know you don't know what it is. That's progress.